Chapter 7 Data Description. For this chapter, you can learn about discrete data and continuous data. First, we'll look at discrete data. And what is discrete data? Discrete data can take exact value. And here are the example of discrete raw data. Now we'll look at the frequency distribution of discrete data. This is a table how a frequency distribution of discrete data look like. We have the number and we have the frequency. So what does it mean by exact value that I see just now? So for example, from this table, we have number 0 and frequency is 4. This means we have 4 number 0. So we can look at the table above and calculate how many number 0 we have. 1, 2, 3, 4. Yes, exactly 4. This is what I mean exact value. The mode. The mode is value that occur most often, or we can say highest frequency. So from the table above, we can see which is the mode. We can clearly see that number 0 is the mode because it has the highest frequency, 4. So the mode is 0. After discrete data, we look at continuous data. For continuous data, we cannot take the exact value, but we're given within a specific range or measure to a specific degree of accuracy. Now let's look at the table of frequency distribution of continuous data. And we can clearly see that there's a range for every class, like 140 to 145, 145 to 150. So the value of 139.5, 144.5, these are called class boundaries or interval boundaries. And how we get the class boundaries is actually very easy. You just need to minus 0.5 for the lowest boundary, for the lower boundary, and add 0.5 for the upper boundary. And there's a relationship between the lower boundary and the upper boundary. You can see it here clearly, 144.5, 144.5. That means the upper boundary for the first class will be the lower boundary for the second class. So the width or the size of the interval, you can use upper class boundary minus lower class boundary. We take the first class as example. So we use 144.5 minus 139.5, and we can get answer 5. That means the range is 5. The class interval, the size of the interval is 5. So here are the table. Normally exam will come out this kind of table. And what did I mean you cannot take exact value is that you can see that the first class 139.5 until 144.5, the frequency is 2. You cannot get exactly value. You don't know the 2 is what number. Maybe it can be 140.141, maybe 140.143. So we don't know. We cannot get the exact value. Stem and leaf diagram, or we call stem plot. A stem and leaf diagram is used to order and present the data given to 2 or 3 significant figures. So each number is split into its stem and leaf. So we'll see the example of 23. Okay, so the in front one, 2 will be the stem. The behind number will be the leaf. So 3 will be the leaf. So if you have 2 sets of the data, it can be compared by using back-to-back stem and leaf diagram. So I will show you later the back-to-back stem and leaf diagrams. So now let's look at the example or the question of stem and leaf diagram, and I will teach you how to solve this. So the number of sheep which anchor at a port every week for 13 particular weeks are as follows. So this is the data. And then how we're going to start the first step of the solution. You have to draw a straight line, okay? And then you have to look for the lowest value and the greatest value, 1 until 5, and you list out 1, 2, 3, 4, 5. Okay, so in front the line will be stem and behind the line will be the leaf. So 1. So there is 2 1 in the example, in the data. So 15 and 18. And we have to arrange it from the lowest to the greatest. So 15, 18. Yeah, so you just do the same thing for the rest. Just do the same thing for the rest, like 21, okay, 23, 28. Yeah, do the following. So let's say, for example, the range is 1 to 5. You have to list out 1, 2, 3, 4, 5, but there's no 30. Like let's say in the data there's no 30. You still have to write the stamp, 3 stamp. You have to write the stamp, okay? Because if you skip this step, like let's say you just 1, 2, 4, 5, you'll be wrong. Yeah, that's the wrong answer. You still have to list out even there's no data. And the key, so we look at the key, 5/0 mean 50 ships. Okay, back-to-back stem and leaf diagram. We will use back-to-back stem and leaf diagram when we have two sets of data. Let's look at the example. Lily recorded the exam result for 16 boys and 20 girls in her school. The result was as follows. We have two sets of data, the first boys and the second girls. So the question is, construct a back-to-back stem and leaf diagram to represent this data and comment on your result. The solution is actually very easy. It is the same as the stem and leaf diagram. So in the middle, we'll put stem, left hand side and right hand side will be the leaf for two different sets of data. So we can clearly see that the data at left hand side is not arranged properly. That means it is not arranged start from the lowest to the greatest value. So we have to arrange it to become the data at the right hand side. So why we did this? It is because the exam question, maybe they will ask the second value of the boys data. If you didn't arrange, your number will be 55. Okay, so your answer will be 55. And if you arrange, your answer will be 50. So obviously 50 is the correct answer. So that means if you didn't arrange, you'll get the wrong answer. And then B, comment on the result. And from this back-to-back stem and leaf diagram answer, we can clearly see that the boys' exam results tend to be lower than girl, because the most of the boys, they get like 40, 50, 60 something, but girl, they will get 70, 80, 90. Yeah, so this shows that the boys' exam results tend to be lower than the girls. We have group data and ungrouped data. First, we'll look at ungrouped data. Measure of location or measure of central tendency. This is a term that always used in the exam question, and we always ignore it because we think that the term is not important, but actually it is very important. You have to remember it. And measure of location or measure of central tendency means that mean, mode, and median. Mean is the average value, and this is the formula. We have to memorize all the formula because in the exam they will provide the formula for you. You have to memorize on your own. Okay, so mean is sum of x divided by number of data. And mode is the value that occur most often. Median is the middle value of a set of data. Let's say this set of data. Okay, we'll find the middle value. Cut. Okay, this is the median. If let's say we have 6 number. Okay, cut this 2. Okay, the median is in between 3 and 4. So 3 plus 4 divided by 2 to get the value of median. Okay, so to calculate median, you have to divide n by 2. Okay, is when n divided by 2 is a whole number. Let's say after you divide, you get 3. So the third value will be the median. So from this we can see that 1, 2, 3. This is the third value. So 3 will be the median. So when n divided by 2 is not a whole number, let's say we get 4.5. After you divide, you have to round up the number. So that means you directly round up to 5. Even it is 4.1, you also have to round up to 5. Measure of dispersion for ungrouped data. We also have to remember measure of dispersion. Measure of dispersion means range, quartile, interquartile range, semi-interquartile range, variance, and standard deviation. So start from range. So how we are going to get the value of range? We use the greatest value minus the least value. So quartile divides the data into 4 parts. This means number of data divided by 4 is Q1. Q2, also called median, n divided by 2, and Q3 is 3n divided by 4. So to calculate Q1 and Q3, you have to divide n by 4. So when you divide n by 4, so number of data divided by 4, it is a whole number, so we find the midpoint of the corresponding term and the term above. So when n divided by 4 is not a whole number, so you also have to round up the number and pick the corresponding term. Interquartile range, that means you use Q3 minus Q1. Semi-interquartile range, that means you have to divide by 2. The interquartile range you have to divide by, or you times with 1 over 2 or divide by 2 is the same. Variance is, you have to memorize the formula. Sum of x squared divided by n minus mean square. And the standard deviation is the square root variance. So let's look at the example. Find mean, mode, first quartile, third quartile, and semi-interquartile range for the following. So A and B. The solution for A. For A, we have 10 number in this set of data. So n divided by 2, that means 10 divided by 2. And you will get 5. This is a whole number. So you have to find the median. This is a whole number, that means you have to find the midpoint. After you cut all, you find that the median is in the middle. So you use 5 plus 5 divided by 2. So it will equal to 5. So the mode is the highest frequency. So 7 is the highest frequency. So it is the mode. So for first quartile, n divided by 4, 10 divided by 4, and you get 2.5. When you get something that is not a whole number, you have to round up, and you just pick the value. You round up, it becomes the third value. The third value, you look for the third value. 1, 2, 3. The third value is 3. So we just put 3 there. So third quartile, 3 times 10 divided by 4. You get 7.5, and you round up is the number 8 value. So you calculate 1, 2, 3, 4, 5, 6, 7, 8. So the 8 value is 7. So you just root 7 there. So that's your answer. So semi-interquartile range, you just divide, you just 1 over 2 times with Q3 minus Q1, you get the answer. So when you see this kind of question, is very easy, but you also have to be careful because sometimes they didn't arrange for you. Like B, if they didn't arrange for you, let's say you do the median, 9 divided by 2 is 4.5, and you round up to 5. If you didn't arrange it, you will get the number 9. The answer will be 9. But that's a wrong answer, because when you arrange, the answer is 8. So you do the same step for the other. Box plot. This is how a box plot look like, and usually we will draw in a graph paper. So you just have to remember the first line you draw this is the lowest value, there is not an outlier. Then you draw a square. The first line of the square is the Q1, lower quartile, and middle line will be median, and the third line is upper quartile, Q3, and the last line is highest value, there is not an outlier. We also have outlier, and I will explain later. Outlier is an extreme value that lies outside the overall pattern of the data. An outlier is any value which is there is 2 Q3 plus 1.5 bracket Q3 minus Q1. So any number after this number will be the outlier, and Q1 minus 1.5 bracket Q3 minus Q1. So any number below this number will be outlier. So let's give an example. Let's say the overall pattern, like most of the students they get 50 something for their exam, like 51, 52, 53. The majority of them get this number, and suddenly there's one student he get 100, and one student he gets 0. This means this two will be the outlier because the value is extremely big, because the range is extremely big. After ungrouped data, now we come to group data. Measure of location or measure of central tendency. It is actually different for group data and ungrouped data, but the things inside still the same. We also have mean, mode, median, but we'll have an additional one, model class for group data. The formula of mean for group data is actually different with the ungrouped data because of the frequency. The equation is sum of frequency times with x divided by total frequency. And the model class is the class with the highest frequency. And the mode is different with the ungrouped data because ungrouped data we can see the value, we can get the exact value, but group data we don't know the exact value. So the formula of group data to find the mode is L plus change in 1, difference 1, change in 1 plus divide by change in 1 plus change in 2, or difference 1 plus difference 2 time with the C. So L is the lower boundary of the model class. The change in 1 is difference between frequency of model class and the class before it. Change in 2 is the difference between frequency of model class and class after it. C is the width of model class. And the median also different. You also have to memorize this. So median is low L plus bracket n divided by 2 minus f, the big F, divided by small fm, then bracket times with C. So L is also the lower boundary of the class contained median. F, the big F, is the cumulative frequency preceding L. The small f, m, frequency of class containing median, and C is the class width of median. Measure of dispersion. So if you want to get a range, you can use midpoint of highest class minus the midpoint of lowest class. So Q1 and Q3 quartile is the same as the median. So the only thing different is divide by 4. It's not divide by 2. Okay. So semi-interquartile range, you use 1/2 times with Q3 minus Q1, and the variance is the sum of fx squared divided by the total frequency minus mean square, and the standard deviation will be square root variance. Okay, now let's look at an example. This is how the question in exam. So they'll give you the age and they'll give you a frequency, but they won't give you the cumulative frequency of called big F. For this you have to calculate it on your own. So first is 3. So we start with 3. Because this is a cumulative frequency, so we have to use this 3 plus with the frequency for the next class, and we get 9. So you can do this for the rest and we get a total 75. And now we're going to find mode. So we want to find the value of mode. The first thing I have to do is find the model class. Model class is the class that have the highest frequency. So this is the highest frequency. That means this is the model class. Okay. So L is the lower boundary of the model class. So 20 minus 0.5, and you will get 19.5 plus bracket change in 1. Change in 1 means that the difference of the frequency of the model class before it and after it. For before it is change in 1. For the class after it is change in 2. So 25 minus 15. So the difference is 25 minus 15, and you will get 10. 25 minus 15, you get 10. And then 25 minus 16, you get 9. Okay. And the CC is the class width. You have to use the upper boundary minus the lower boundary of the model class. So 24 plus 0.5, 24.5 minus 19.5. So you get an answer 22.1. So for median L is the lowest boundary of the median, that containing median, because we have 75 frequency. The frequency is 75. So we divide by 2. Divide by 2 and we'll get the number 30 something, 37.5. Okay, so where is the median? You have to see the cumulative frequency. So this is 3, that means no. 9 also no, because it is 37, and suddenly 49. So that means it is in this class. So it is in the same class. So lower boundary also do the same. 20 minus 0.5, you get 19.5. N divided by 2. So N is the cumulative frequency. The total of frequency, not cumulative frequency, is the total of frequency, 75. Divided by 2 minus big F. So big F is the cumulative frequency preceding L. That means the cumulative frequency. This is the L. This is the class that containing. This is a class that containing median. So the cumulative frequency preceding L. That means the cumulative frequency before this class, 24. So we fill in 24 here. And Fm is the frequency of the median class. The frequency of the median class is 25. So this is 25. And then time with C. You get a number, you get a value 22.2, the answer. Skewness of distribution. We have 3 types of skewness of distribution. The first, symmetrical distribution, negatively skewed distribution, and positively skewed distribution. The first row is how the histogram will look like. You just have to know. The second row is a box plot, how the box plot will look like. And I think the most important is this row. You have to remember. And how you are going to remember, the median is always in the middle. You just have to remember the median is always in the middle. If let's say mean greater than median greater than mode, that means it is a positively skewed distribution. If mode greater than median greater than mean, that means it is a negatively skewed distribution. For the symmetrical distribution, it's very easy because mean equal to median equal to mode. So for the second last, this is when the question asks what is the measure of central tendency or measure of location is suitable for this type of skewness. For symmetrical distribution, mean is the most suitable. For negatively and positively skewed distribution, they are the same. Median is the most suitable. Okay. So for the last row, they will ask what kind of measure of dispersion is the most suitable for determine this kind of skewness of distribution. For symmetrical distribution, standard deviation is the most suitable. For negatively and positively skewed, they are the same. Interquartile range are the most suitable. Pearson coefficient of skewness. For Pearson coefficient of skewness, we have 2 formulas. So if we have the mode, we'll use the first formula. If let's say we have the median, we will use the second formula. If let's say the question didn't mention which formula to use because we have the mode and median, I would recommend you to use the second method, second formula. That's all for this video, and I hope you can learn something from this video.